Greetings to you all. Sanibonani, Dumelang. So today we'll be doing the geometric series and also do the sigma notation. So let us start.
Now let us do the geometric series. Now a geometric series is the sum of the geometric sequence. Now let's say the sequence is 3, 6, 12, 24 is a geometric sequence, and the sum of that will be 3 plus 6 plus 12 plus 24, etc. When you add the what to call the terms of a sequence, you get what? You get a series. Now the sum of a geometric sequence formula. Now the formula allows you to determine the sum of the first n terms of what? Of a geometric sequence. Now this is the formula that we're going to use. Okay, so that will be what? That will be Sn is equals to a, which is the first term, r to exponent n, r being the constant ratio, and n being what? Being the number of the first terms, and the Sn being what? Being the sum of the first n terms. Okay, now or you can use this one. Okay, just that we rearranged what's in bracket and the denominator there. Okay, these these variables are still there, the same. Now with example 1, finding what? Finding the sum. So we are asked to find the sum of the first 20 terms of the series. Okay, first we need to find a, which is the first term, t1, which is equal to 3. Okay, now we need to find what? The ratio. Now the ratio is going to be t2 over t1. Okay, we must also confirm if the ratio is constant. Okay, by doing what? By finding another ratio. Another r will be t3 over t2. Now t2 being 6 over 3. Now what is the answer there? The answer is 2. And then here, what is t3? T3 is 12 over 6. The answer is 2. So we have a constant ratio of how much? Of 2. Constant ratio of what? Of 2. So we are asked to find what? The sum of the first 20 terms. Now we know that we are looking for 20 terms, n is going to be 20. So we use our formula for sum. That will be the sum of the Sn is equal to a into Rn minus 1 all over r minus 1. So we are looking for the sum of the first 20 terms. A is what? A is 3. That will be 3 into because r is 2 to the exponent 20 minus 1 all over 2 minus 1. So you punch all this in your calculator. That will be 3 to 20 minus 1 to minus 1. So our answer here is going to be 3,145,725. Okay, that will be 725. This is going to be the sum of the first 20 terms that is given by this series. Okay, now let us now do example 2 finding what? Finding when the number of terms is not, when finding the number of terms when it's not known. Okay, now the first question is, okay, consider the geometric series, this one. Okay, the first question, how many terms are there in a series? So we do not know how many terms are there here. Okay, now if you want to find the what you call the number of terms, we'll start by using the general term equation. Okay, that will be your Tn is equal to a Rn minus 1. Okay, because we know that term number there, we know the term number. This is not the sum, it's a term number there, we know this one. So we are going to substitute it there. We know AA is the first term, so we'll have to find what? We'll have to find R. So what is A? A is equal to 0,25. We're told this is a geometric series, so it has to have a constant, it has to have a constant ratio. So ratio is going to be T2 over T1, which is equal to 0,5 divided by 0,25. Okay, and we need to confirm the constant ratio T3 over T2, which is going to be equal to 1 over 0,5. So I'm going to have 0,5 divided by 0,25. So the answer here is 2. Okay, now here I'm going to have 1. The answer is 2. Now we have what? A constant ratio. So we're looking for n. So this is going to be 256 is equal to what? 0,25. Okay, 0,25 into 2n minus 1. Okay, so from here what do? We're gonna divide both sides by 0,25. This is going to cancel that. I'm gonna have 256 divided by 0,25. The answer is 1024. 24 is equal to 2 to the exponent n minus 1. Okay, so now how do we bring this down? Now we apply the logs. Okay, the law of the logs. So with the laws of the logs, we say the log of this number base 2, because this is the base, it's equal to what? It's equal to the exponent. Okay, I'll write it there. We say log of what? Log of number base is equal to what? Exponent. Okay, now what is the number? The number is this one. The base is that one. Is equal to what? The exponent, which is that. So we're gonna say log of 10 24, the base is 2, is equal to n minus 1, like that. Okay, n minus 1, like that. And then we're gonna transpose this one to this side, so we're going to have log of 1024 base 2 plus 1 is equal to n. So n is going to be equal to, we have it there, base 2 1024 plus 1. So the answer here is 11. So there are 11 terms in this series. There are 11 terms in this series. So that was A. So let us now come to do what? Let us now do B. What is the sum of the series? So we know A, we know R, we know N. So Sn is going to be equal to a into r to the exponent n minus 1 all over r minus 1. So the sum of 11 terms is going to be a 0.25 into 2, 11 minus 1 all over 2 minus 1. So this is going to be, this is our b. Okay, this is going to be 0.25 into 2 to exponent 11 minus 1, 2 minus 1. The answer is 511, 75, 511,75. That will be the sum of the 11 terms. So in this series there are 11 terms. That's how we do it. Let us now do example 3. Okay, now example 3, finding the term number n when the sum is known. Okay, so this one, you know, the sum, we say consider geometric sequence -1, 2, -4, 8 will add up to, so we know this one is not a term. This one is what? This one is Sn. Okay, so now what do we have? We've got a is the first term is -1. It's a geometric sequence, so it has to have what? It has to have a constant ratio r t2 over t1, which is equal to 2 over -1, which becomes -2. And then we confirm the constant ratio, say t3 over t2 is equal to -4 over 2. So this also gives us -2. Okay, so we're looking for n when we know the sum. So from here we're gonna use what? We're gonna use the formula for calculating sum. That will be Sn is equal to a rn minus rn, sorry, minus 1 over r minus 1. So we know the sum. The sum is 349,525. It's equal to, what is a? A is -1, right? -1 into and then r is -2 to the exponent n minus 1 all over r is -2 minus 1. Okay, this is going to be 349,525, which is equal to this is going to be it's just saying this is going to be -1 into -2 n minus 1 over -3. Okay, so this negative and this negative, they're going to cancel out. Okay, and 3 times that, we're gonna say 349,525 times 3. This is going to be 10,48575. Okay, 1,048,575. This is going to be equal to, now we're gonna have what you call -2 to the exponent n minus 1. Okay, so we're going to do what? We're going to transpose this -1 to this side of the equation. Now we're going to have is equal to -2. Okay, -2 to the -2 to the exponent n, like that. Okay, so now we're looking for that n, which is n exponent. From here we can say, because we do not want to work with the what to call negative basis, so if we use a negative base, we are going to get an undefined. Let's say, for example, if you use the log number here, it's what is 10 48 576 base. The base is negative there. It's going to say what? It's undefined. It gives us a math error. So, but we can use an alternative method. We can find what to call the prime factor of this. We can say, okay, 10 48 576 is equal to, and we look for what we're looking for that. So we can see that this is going to be 2 to the exponent 20. Okay, but how are we going to use this 2 now to our advantage, so that we don't have that -2? We're gonna say this is going to be -2 inside a bracket to the exponent 20, which is equals to -2 to the exponent n. Okay, so let us check that. -2 to the exponent 20, what do we get? We get that. Okay, so this is going to work in our advantage. Okay, so when the bases are the same, we can simply equate the exponent. So n is equal to what? N is equal to 20. Okay, just like that. So if you get a math error, try to use the method that I just showed to you right now. Okay, good people, that will be the end of my lesson. I thank you.